So, and I give you a table, and in this table, I give you the extinction coefficients, all these parameters. Then you just need to plug in your sensor data. Then you will be able to get SpO2. And then one thing to make this more accurate is to consider that light doesn't travel in straight lines in tissue. They take zigzag traces, and depending on the wavelengths, their travel distance can be different. And this is captured by something called differential path factor, DPF. And DPF, red light, red light versus infrared is a constant, which is 1.3 to 1.4. So you just need to plug in DPF into this original formula. Then you will be able to get this. This is more accurate. And in practice, pulse oximeters often use experimental data for calibration. So instead of just use these values in the literature, you can define 4 different parameters, K1, K2, K3, K4, and you will be able to get more accurate SpO2. Go ahead.
Why is it plugged into those spots specifically? Is that just how the derivation works out?
Oh, I mean
the differential path factor.
Yeah, this is the DPF of R versus IR. So that's why you plug this into the term of R, not IR. This is the extinction coefficient of IR. This is the extinction coefficient of R. Then this parameter is defined to correct for their different path lengths. Yeah, go ahead.
So IR is not affected by DPF.
It is. So this is DPF is essentially the ratio of their different travel distance.
Right.
DPF R versus IR. So this is a ratio.
Oh, I see.
This is about 1.3 to 1.4. So that means red light travels a distance of 1.3 times of IR. Okay. There are different pulse oximeter parameter setup. So on the left one, the first one is transmittance mode, which is the mode we use in standard pulse oximeter, the medical device. So we have a red light, we have an infrared light, then they travel through your finger and reach the photodiode. This is the transmittance mode. So this mode has higher signal quality and is less sensitive to movement, but it's limited to 2 thin body parts like fingers, and then there's a reflectance mode where we place the LEDs and the photo sensor on the same side. So light goes into your finger, then is reflected back to your photo diode. So this also works, but it has low signal quality. It's more sensitive to movement. But this is useful for many body parts. You can put it on your arm or on different body parts. That works. But the first one can only apply to thin body parts. That's the limitation.
No, sorry.
Okay, yeah. Sorry. Yeah. Okay. So, and we'll be using this in our lab so that we can put it on different body parts. All right. So then we are going to talk about SpO2. As I said, SpO2 is your T